Hi, our names are Susanna and Andy. Early on, we were very interested in the proliferation of hate speech on social media and that problems ties to topics that we've encountered in CS 224U.
The motivation behind this was just social media platforms are meant to connect, but usually end up becoming very divisive environments. A dataset that we found that was novel was Davidson et al., in that it was the first to differentiate between hate and offensive speech, moving away from a binary approach to this three-class system.
Our hypothesis was that many of the misclassified tweets were issues with the lack of context surrounding the tweet. So we thought that adding handbuilt features to capture some of this context manually would help a classifier identify hate speech better. We also thought that using sentence-level embeddings would help us to capture this context better than other lexical features could. We decided to run Davidson et al.'s logistic regression model with syntactic features as our baseline model, adding our own features on top of those.
And so some of these, to capture information about culture, we decoded slang by building up files with common abbreviations, acronyms, misspelled words, slangs for terms. We loaded this into one dictionary and ran the tweet through to replace all terms in the tweet that were in the dictionary with a value for their keys. For example, hundo P is replaced with 100% certain, trill with real true. This allows us to capture more sentiment information of the decoded slang term. The self-referential feature aims to identify tweets that could be classified as hate speech but are said by someone as part of that in-group. The contains quotes feature is a similar attempt to capture hateful terms that are being treated as hateful terms in the context of commentary against them. Davidson's results, as pointed out by Wang's analysis, were biased against women in that hate speech targeted at women was regularly labeled as offensive. Our feature is offensive to women, is focused on handling the tweets that are hateful against women.
We also utilized Flare, an NLP library with a built-in embedding library that has its own embeddings drawn from sources like Twitter and the news, as well as providing BERT and Elmo embeddings. We decided to use Twitter, news, and BERT embeddings in several combinations. Our preliminary results are based on the training data, and we will continue to test on the test data on a held out set of the data set for our test data. Preliminary results show that the Davidson baseline has 43% recall on the hate speech category, as well as 75% recall in the neither category. We see a small increase to 45% recall of the hate speech class for BERT, news, and Twitter embeddings all combined, and an increase to 86% recall of the neither class. An interesting thing that we found was for only hand-built features, recall of the hate speech class goes down 2%, while recall of the neither class actually goes up 2%. We plan to combine hand-built features and embeddings when running the test set.
So for future work, one big constraint for us was just the labeling of the data. So we think that if there's better labeled data, more equally balanced between offensive hate speech and neither classes, and also verified by an expert in the hate speech space, would do a lot to improve future work. Another thing is an analysis of labeling by members that belong to cultural groups as well as gender groups, and if seeing the difference between their labeling as opposed to just the general crowdsourced groups labeling.
And we also hope to try future work would require doing more models aside from logistic regression, such as LSTMs or neural networks.